If I were given this polynomial and I was asked to find all of the possible rational roots and then determine which of the possibilities were actual roots, I would do P over Q, find all the factors of P, divide them by all the factors of Q, then simplify. Please look at a previous video if you do not know what I am talking about. And please take note that in this case, there was no leading coefficient, but there's an imaginary 1 there. So I know that the leading coefficient was 1, and so I knew that Q was 1, and that's how I did that. So then I would have to go ahead and figure out which ones were actual roots. I can use synthetic division. I can take what I listed as possibilities. I can take positive 1, I can take negative 1, positive 2, and negative 2, and I can use synthetic division and figure out which one of those would give me a remainder of 0. If it gives me a remainder of 0, I know that it's a root. But I don't feel like doing all of that synthetic division. Instead, I'd like to use the remainder theorem. The remainder theorem tells me that if a number is a factor of a polynomial, I can substitute that number into the polynomial, and if the remainder is 0, it's a factor. So the remainder will be 0 if, when I substitute the number into the polynomial, I get 0. If the remainder is 0, then that means that that number that I substituted in there is a factor. If I was asked to find all of the possible rational roots and then determine which of those rational roots were factors, then I would have to first do P over Q, find all the factors of P divided by all of the factors of Q, simplify them, and find all of my possible rational roots. And then in this case, my possible rational roots are positive 1, negative 1, positive 2, and negative 2. Take note, I found that there was no Q, but I know that there is an imaginary 1 in front of the variable, so I knew that Q was 1, and that's where I got the plus or minus 1 from for Q. So at this point, I could do synthetic division. I could take 1, do the synthetic division, find out if the remainder is 0. If the remainder is 0, the factor theorem tells me that if the remainder is 0, then 1 is a factor. I would do that with negative 1. I would do that with 2. I would do that with negative 2. I don't feel like doing all of that. I don't feel like doing all of that synthetic division. So instead, I am going to use the remainder theorem to help me with the factor theorem. So the factor theorem again tells me that if I do synthetic division and I get a remainder of 0, then the number that I used in my synthetic division is a factor. But the remainder theorem says that I can take any number that I'm going to use within synthetic division. So I'm going to take this 1 and I'm going to substitute it into the polynomial. And it will automatically tell me what the remainder is. I don't have to do the division. I can take the number that I'm going to be dividing. So I'm going to take 1, substitute it into the polynomial, and when I do this, it will tell me my remainder. So let's do it. I'm going to have 1 cubed. 1 cubed is 1. 1 squared is 1. So 9 times 1 is 9. And then I'm going to have negative 21 times 1, which is negative 21, minus 2. 1 plus 9, 1 plus 9 is 10, 10 minus 21 is negative 11, negative 11 minus 2 is negative 13. Negative 13 is my remainder. The remainder theorem says if I do f of 1, this right here is my remainder. The factor theorem says that the remainder has to be 0 in order for it to be a factor. So 1 is not a factor because the remainder is not 0. Let's try negative 1. In this case, I would have negative 1 cubed, which is negative 1. Negative 1 squared is positive 1, so 9 times positive 1 is still 9. Negative 21 times negative 1 is positive 21 minus 2. And in this case, negative 1 plus 9 is 8. 8 plus 21 is 29. 29 minus 2, 27. So that tells me that if I was to do the division, synthetic division or long division, that would be my remainder. I'm trying to find factors. I need my remainder to be 0. So negative 1 is not a factor. Let's try 2. So I've done 1. Nope. I've done negative 1. Nope. Now I'm doing 2. So 2, I have 2 cubed plus 9 times 2 squared minus 21 times 2 minus 2. 2 cubed is 2 times 2 times 2, which is 8. 2 squared is 4. 4 times 9 negative 21 times 2. So then I'm going to go ahead and say 8 plus 36 is 44. 44 minus 42 is 2. 2 minus 2 is 0. So that means that 0 is my remainder. I'm trying to find out if 2 is a factor. It is a factor because I used the remainder theorem to find the remainder. I found the remainder to be 0, which means that 2 is a factor based on the factor theorem. So 2 is a factor. I will try to see if negative 2 is a factor as well. So if I were to do negative 2, I will find that it's not a factor. So don't waste your time, or you can and get the practice in. You will not get a remainder of 0. So now that I've found that 2 is a factor, I could go ahead and now instead of doing the synthetic division for all of that, I would just do it for the one I know is a factor, which is 2. I would use my coefficients 1, 9, negative 21, negative 2. Bring down the 1, 2 times 1, 2, 9 plus 2, 11, 2 times 11, 22, negative 21 plus 22 is 1, 2 times 1 is 2, and look at that. I already knew I was going to get 0 because the remainder theorem told me that I would get 0. If I were to use negative 1 into the synthetic division, the remainder would be 27 because I did the remainder theorem and I found that the remainder would be 27 if I use -1. So I'm good so far. I know that 2 is a factor, but now I'm left with x squared plus 11x plus 1, and I don't have anything else to divide into it because I already checked the other possible rational roots, and they're not roots, so I can't use those. So at this point, I'm not freaking out though because I have gotten it down. I had a cubic and I got it down to a quadratic. I can use the quadratic formula to find my other roots, to find my other solutions. Quadratic formula says x equals -b plus or minus the square root of b squared minus 4ac all over 2a. I like to rewrite my quadratic formula, but I like to write it with blanks for my variables so that I can go ahead and substitute in the numbers. That's ugly, sorry. So I'm going to go ahead and take b, which is 11, substitute it where b goes, take a, which is 1, take c, which is 1, and then when I do the quadratic formula, it's -11 plus or minus the square root of 11 squared, -4 times 1 times 1, (121 minus 4) is 117. Yes. There you go. I found my roots, positive and negative. My answer to what are the roots of this polynomial? The answers are, I have x equals 2. I have -11 plus the square root of 117 over 2, -11 minus the square root of 117 over 2.